Okay, this is the second video for hypothesis testing. So this does the actual problems where you kind of put everything together. Um, so the only part I haven't explained yet is how to interpret the decision, because that comes after we talk about the steps. So I'll do that on here too. So your steps for hypothesis testing, you're literally, when you do these, you're going to write down number one, do number one, number two, do number two, and so on. So you're going to write the hypotheses and label the claim is step number one. Number two is decide on your sampling distribution, if it's a normal or a t-distribution. It's the same, that refers to the means. We're going to be doing the means and proportions. Proportions, it's always going to be done the same way. For means, it's a normal or a z, just like on intervals if you know sigma. And if you do not know sigma, it is a t. So just like with our confidence intervals, we did z interval if we knew sigma, t interval if we didn't. Same kind of thing for hypothesis testing. Step number three is the most involved step. You find the necessary sample statistics and the p-value. You can do these without finding the p-value. It's not required if you do it by hand. You do have to find your sample statistic, your test statistic. So I'll show you how to do it two ways, by hand, and then you're probably going to want to do it the calculator's way. The calculator's way, you'd just be using a p-value. And then you make a decision, and then you interpret the decision. So to interpret the decision, you always look back at the claim, and there's a easy way to set them up so that you remember what to do, what to say. So I'm going to show you that as well. If the claim is the null hypothesis, HO, you will either reject the claim or determine that there is not enough evidence to reject the claim. And if your claim is the alternative hypothesis, your H1, you will either support the claim or determine that there is not enough evidence to support the claim. So that's why when we've been doing the hypotheses, I've been putting parentheses claim. That's part of the reason, because you need to know if it's your null or alternative hypothesis. And then there's another little trick, so you'll remember what your word to use. If it's HO, you have to use the word reject, and if it's H1, you have to use the word support. So to get started on an example here, it has been reported that the average credit card debt for college seniors is $3,262 with a standard deviation of $1,100. And this implies that that means for all college seniors. The Student Senate at a large university feels that their seniors have a debt much less than this, so it conducts a study of 50 randomly selected seniors and then finds that the average debt is $29.95. With alpha equal to 0.05, is the Student Senate correct? So, to do this by hand, the first thing you want to do is write your claim. So, what we are testing, it says the Student Senate at a large university feels that their seniors have a debt much less than this, than what is reported. So, they feel or claim, it's another, you could play in the word claim instead, that the mean, average credit card debt, the mean, is much less than whatever is reported. What's reported is $3,262. So that is their claim. And if you want to go back and reread the problem and label your information, that's fine. Like I said, this has been reported for college seniors. The word all is implied. So standard deviation of 1100 is sigma, the population standard deviation. They do a study of 50, which is N, and find, based off that study, the average debt is $29.95. So there's X bar, and it already has alpha equals 0.05. So step one is write your hypotheses. So this is a strict inequality, which means it goes with H1. That's our claim. And the opposite of less than is greater than or equal to. Now I said there's a trick that you can do in order to remember what word to use, what you're always going to do is write down the word reject next to HO and the word support next to H1. You don't want to? Oh, that's okay.
I want you to step it up.
Okay.
Because I want to crunch them down.
So we're going to write down, here. Okay, go back in there and let me finish. We're going to write down reject and support. And I'll explain when we get to step 5 on why we do that. So you just write that down just as keywords. Just don't forget to write it down because it's going to help you in the end. And then step 2, decide if you're using a normal or a t-distribution. For this one, we know sigma, we said it's a population standard deviation, which means it's a normal or z distribution. So what you're going to do is, to do this by hand, you're going to have to find your test statistic. And like I said, you can do either then a p-value or your critical value. You can pick one or the other. So for step 3 here, we're going to find our test statistic. And so you'll recognize this formula. So just like before, you do X bar. Our X bar off our sample that they did is 29.95 minus the reported mean for college seniors, which is 32.62, divided by, if you remember, this is sigma divided by the square root of n. So we've used this formula before, so plug all that in. It'll give you a z value of negative 1.72. So that is your test statistic. So now you can do your, determine if you're going to reject or fail to reject 2 ways. You can either do your critical value or you can do your p-value. So let me start with, I'll start with critical value. So if you were to draw this to find your critical value, because what we were doing before, I went over how to determine, you can use p to alpha, or you can determine if your test statistic is inside or outside your rejection region. Same thing. So alpha is 0.05. You have to know, is it the area in the left, the right, or both tails? So remember how to do that is by looking at H1. It's a less than. So if it's a less than, that means it's a left-tailed test. Let me just back up here and put a left-tailed test, which means that alpha is the area in the left tail. So that means this is alpha 0.05. So to find the critical value, you do the inverse norm of 0.05, and it gives you negative 1.64. And you compare your test statistic, negative 1.72, it's to the left of negative 1.64, which is inside this shaded part. And if you remember, the shaded part is the rejection part. So based off your test statistic and critical value, you would reject HO. So that is step 4. You decide. That is using critical value and test statistic. Your other option, which I'm going to do over here, so this is an or you can find your p-value if you want to do it using a p-value. For the p-value, you do not need the critical value. So basically, you would still do this step of getting your test statistic. And then we still need to know if p-value is going to be the area in the left tail, the right tail, or both tails. So you still have to know if it's left-tailed, right-tailed, or two-tailed. So it's still a left-tailed test. It's still less than. So our p-value is going to be here. Our test statistics, negative 1.72. So we can go to our chart. It's the area to the left. Makes it a little bit easier. Negative 1.7 over to 0.02, we get 0.0427. and that would be our p-value. And then you can make a decision. So this would be step 4. You could make a decision by comparing your p to alpha. So 0.0427 compared to 0.05. 0.0427 is less than 0.05. And if p is low, we reject. HO. So you can either do it either way. You don't have to do it both ways. Either if you do this by hand, actually when you do this on the calculator, you won't even have to do this step here or find in your test statistic. It'll give it to you. But when you do this by hand, you're going to start with the test statistic every time, and then you can either find your critical value and see if it's in the shaded, if your test statistic's inside your shaded region or not, or you can find your p-value based off the test statistic and not do this and compare p to alpha. So those are your two options. And you don't have to do it both ways. You could do it one or the other way if you were doing it by hand. Some people, if they do it by hand, they elect to do it both ways anyways, just to make sure you get the same answer twice, which is fine if you want. When I show you how to do it on the calculator, it's a little bit easier, so you may actually just want to do it on the calculator and not necessarily do it by hand. Most people don't like this formula, so the calculator takes out you having to plug this in. So then step 5 is to interpret. So basically we've decided that we've rejected HO. Either way, we've rejected HO, which means if you reject something, you can cross it out. So when I reject HO, I just draw an X through it, which means I can circle H1. If I had failed to reject HO, I wouldn't be able to cross it out. I would have to circle it, and then I would cross out H1. So I've crossed out HO, I've circled H1, which means when you interpret, like I said, if you remember to write down reject and support up here, you can always look, if you've got your claim labeled, whatever word's next to claim is the words you have to use in your interpretation. If it's up here, you'd have to use reject. If it's down here, you have to use support. So that's your indication of, do I have to use the word reject or do I have to use the word support? So for this problem, my claim is next to support. I have to use the word support. Well, I have it circled. I don't have it crossed out, which means I support the claim. If you had a big X through it, you would say there's not enough evidence to support the claim. Since I have it circled, I'm going to say that there is enough evidence to support, and you can say if you want the student sentence claim, I think, yeah, the student sentence claim. So, and then the question says, is the student sentence correct? You've supported their claim, so your answer would be, yes, it appears that they are because we've supported it. So that is how you do a hypothesis test by hand for the mean. If you, to do it on the calculator, it's a little bit easier. So using the calculator, I'm going to number our steps again. Step 1 is the same. So I'm just going to write down what changes. Step 2, sigma is still known. So it is a normal z, but instead of doing the test statistic and so forth, you're going to do this on the calculator. So just like before, if we knew sigma, we use z interval. Now we're doing a test. So sigma is known, we're going to do z test. And then step 3, let me do z test first, then I'll talk about step 3. So what you're going to do is you're going to go on the calculator, go to stat tests, and you see z test and t test are the top two. So z test should be first. Your input is on data. If you have a list of data, it's on stats. If you're given the stats, which we are in this problem, so switch it to stats. Just go over to stats, hit enter. The first thing you type in is whatever's on the right-hand side of your hypotheses. So for us, that is 30,262. Sigma, we have labeled as 1100. X bar, we have labeled as 2995. And our N is 50. And then for this part, you look at H1. So if H1 is not equal to, less than, or greater than, you pick which one it is. Ours is less than. So we go over to less than and hit enter. So you see this says mu sub 0. We've typed in mu sub 0 is 3,262. So basically this is saying mu is less than 3,262. So that's how it comes up with it. And then click calculate. It gives you your test statistic, negative 1.72 if you rounded to, just like we got using the formula. It also gives you your p-value. So it takes all away you having to use the formula. You can then, if you want, you can still do it. So basically it's giving you this. You could still find the critical value and do it this way. But most people elect to just use the p-value because it spits it out. It's 0.0430. Now you might say that's different than what we got. It is slightly, but not by much. It's different because we rounded to negative 1.72. The calculator does not use a rounded value. We rounded and used the chart. Calculator doesn't do that, so it's off. The last couple decimals are off, but it's close enough. So most people, when they use the calculator, they write down the p-value. And then they compare p to alpha, so that part's the same here, this part here. And like I said, you can still use the critical value if you so choose. But that means you'd have to do z-test to get your z, and then you would also have to do inverse norm to get your critical value. 0.0430 is less than 0.05, so either way we reject HO. And then step 5 is the same. So for these, so that one I did all by hand and then showed you the 2 options for step number 3. Generally speaking, I just do it this way because this way is the quickest way. So for number 2, you have, suppose you work for a national health service and are asked to test the fact that a new company claims, so here's our claim, so let's write down our claim, that the mean sodium content in one serving of its cereal is no more than 230 milligrams. So no more than means it can't be bigger than 230, so we have to be less than or equal to 230. You find that a random sample of 52, which there's our N, has a mean sodium content of 232 milligrams, so there's X bar. And a population, they're nice in this one, give you the word population, standard deviation of 10, so there's sigma. Use a significance level of 0.05, there's alpha, to test the company's claim. So step 1, write your hypotheses. This has an equal to, that means it goes with HO. That's our claim. Opposite of less than or equal to is greater than. And remember, if you write reject and support, you'll remember what word to use when you interpret. Claims next to reject, we're going to have to use the word reject. And if you want, you can make a note of what top-tailed test this is. For this one, it's greater than. It would be a right-tailed test. When you're doing this on the calculator, it actually doesn't matter if you know that or not, because the calculator gives you P. If you're going to do P to alpha, the only time it would matter is if you actually do the inverse norm and do the critical value, then you'd still have to know, even if you use the calculator to get your Z, your test statistic. But if you're looking at P and just comparing P to alpha, it doesn't matter if it's which area it's talking about, as long as you correctly compare P to alpha. So you don't necessarily have to know that to do this on the calculator. But anyways, so step 2, you decide on what type test you use. We know sigma gave us the population standard deviation, so sigma is known. So we do z-test. I'm going to just do this one on the calculator. Step 3, I'm going to get my p-value. So what I want to do is go back to the calculator. I'll go back to stat, go over to test, change my numbers. So now my right hand side of my hypotheses, my right hand side of claim is 230. My sigma I have labeled as 10. My x bar is 232. N is 52. And this time our H1 is greater than, so we have to go over to greater than, hit enter. Go down to calculate, hit enter. And there is your test statistic if you prefer to do it that way by the critical value. But all you really need is the p-value in order to complete the problem. So 0.0746 is my p-value. Then I'm going to compare p to alpha. We've got 0.0746 compared to 0.05. 0.0746 is greater than 0.05. If my p is bigger than alpha, that means I failed to reject HO. If I fail to reject it, I cannot cross it out. It means I have to circle it, which means I could cross out the other one. You're only ever going to circle one and cross out one. You can't cross out both. So fail to reject HO. So then when you interpret, remember, look what word's next to claim. It's reject. I either have to say that I reject the claim or that there's not enough evidence to reject the claim. Well, I didn't reject it. I failed to reject it. So I have to say there is not enough evidence to reject the company's claim. And when you read these in books and stuff, they'll usually say the claim that the mean, what was this one, sodium content is less than 230 milligrams, or is no more than 230 milligrams. But as long as you use the correct words, you can just abbreviate and leave it at whatever just say the claim. That's fine. Saying that there's not enough evidence to reject it is not the same as supporting it. If you can't reject it, that means it may or may not be true. It's just you don't have enough evidence to reject it. So that doesn't necessarily mean that you support it. So that's why you have to be careful. Depending on where your claim is what words you use. So, for stats, just like with the intervals that we were doing, our confidence intervals, we were only, 90% sure that the mean was between these two numbers. Maybe, it may not be. And like just for this one, we're not enough evidence to reject the company's claim, but we're not going to necessarily support it either. We're just going to say that we can't throw it out. Statistics generally is not an exact science. For number 3, you have a simple random sample of the weights of 19. So there's N, green M&Ms, has a mean of 0.8635 grams. So there's X bar. Assume the standard deviation of all, uses the word all, green M&Ms is 0.0565 grams. So that's sigma. Go back that way. Use a 0.05 significance level. So there's alpha. To test the claim, so here's our claim, is that the mean weight of all green M&Ms, that the mean is equal to 0.8535, which is the mean weight required so that M&Ms have the weight printed on the package label. And then it asks you a question we'll talk about at the end. So, step 1, label your hypotheses. Equal to goes with HO. That's my claim. The opposite of equal to is not equal to. Still write reject and support. Again, we're going to either, this time claims next to reject, so we have to either say we reject it or we don't have enough evidence to reject it. Step 2, we know sigma So we're going to do z-test. And we're going to do that on the calculator and get our p-value. So go back to the calculator, go to stat, test, z-test. Right hand side this time is 0.8535. Sigma is labeled, we have labeled, it is 0.0565. X bar I have labeled as 0.8635. N was 19. And this time H1 is not equal to, so hit not equal to and hit enter, and then click calculate. So this time our p-value is 0.4404. Compare p to alpha. So I've got 0.4404 compared to 0.05. 0.4404 is greater than 0.05, so I fail to reject HO. Again, if I...
Why can't you just...
Let me finish. If I fail to reject HO, I can't cross it out, so I have to circle it.
Why can't I talk?
Because it's for my class, baby. Just go back in there. I'm almost done.
But I mean, why can't I talk? Why you are doing this?
Because I need you to be quiet so they aren't interrupted.
Okay. Well, I'll put all that stuff out to make my picture.
Well, you can make a picture. It's hard for 5-year-olds to be quiet. So we failed to reject HO, so we circle HO. We crossed out the other one. Don't dump it out. Just get out what you need. No, it's too loud, Bowden. It's too loud. Now pick it all up. Now you get to pick it all up. Failed to reject HO, so we have to circle it just like last time. And then when we interpret, again, claim is next to reject, so you have to use the word reject. So we don't have it X'd out, we have it circled. So we're going to say there is not enough evidence to reject the claim. And it says do green M&Ms. The question is how, oh, I forgot to fix this. Do green M&Ms appear to have a weight, it's typos in that one, consistent with the package label? So since you couldn't reject the claim, then you can say yes, because we can't throw it out. If we had said we reject the claim, then we would have said no. So those three deal with the hypothesis testing for the mean when you know sigma. Number 4 is a proportion, I think, yeah. So for number 4, we have the company drug test.
I draw on this. Some of this comes off. Then draw my picture.
That's okay.
It does this.
That's okay, go ahead and do it. The company drug test success provides a one-panel THC test for marijuana usage. Among 300 tested, so there's our N, results from 27 subjects were wrong. So just like before, when we did a proportion, we'd use that as an X. Use a 0.05 significance level, so alpha, to test the claim. So our claim is that less than 10%, anytime you see a percentage, you know that's proportion. So P is less than 10% of test results are wrong. So P is less than 0.10. So step 1 is label our hypotheses. It's strictly less than, which means we go with H1. The opposite of less than is greater than or equal to. We still write reject and support next to those. So this time, claims next to support, we have to use the word support. For number 2, step number 2, for proportions, you always use one prop Z test. could spell maybe proportions. Just like for intervals, we always used one prop z int. For proportions, you always use one prop z test. And then we're going to get our p-value. Same way. So we're going to go to stat and tests. And the reason I usually write p-value instead of just p, especially for proportions, is that way you don't get the p for proportion mixed up with the p for p-value. So we go down to one prop z test. Your right-hand side still goes first of our claim, so 0.1. Our x is our little number, 27. Our n is the big number, 300. Our h1 this time is less than, so go over to less than, hit enter, click calculate. It still gives you p hat just like it did for interval, which is fine. It gives you your z test statistic as well. This for p we have 0.2819. Then step 4 is the same. Compare p to alpha. So 0.2819 to alpha's 0.05. So 0.2819 is greater than 0.05, so we fail to reject HO. Which means if we fail to reject HO, we have to circle it and cross out the other one. So we have an X through where our claim is, which means we can't support it. We've crossed it out. So we have to say there is not enough evidence to support the claim. So that is how you would do a proportion. So I think the last three actually do the T's instead of Z's because it does not give you sigma. So I think I'll stop this video here and then kind of split it up into two parts. So part one, or well, I guess three parts if you include the first part of the notes. So I'll do the T tests on the last video. So then that way it's in pieces. It'll be easier for you to find what you need when you're doing homework, hopefully.